So ever since I've had my Miata, it's had these tired set of gauges on them, and recently, in hot weather, this gauge has unpeeled enough to where it's actually touching the needle cup here and preventing the tachometer from working, only when it's hot. So inside this air-conditioned house, it's not an issue, but outside in the Texas summer, yeah, that locks up and that doesn't work anymore, which is unfortunate. So I pulled the trigger on a set of rev limiter gauges, and let me tell you, they are gorgeous. There is one thing that I've noticed, however. All the tutorials, so whether they're video tutorials by other people or even Rev Limiter himself, their tutorials say that you can't set these needles after you've installed your gauge faces. The only one you can set up is the speedometer because it has a stop and a return spring, and it just always points at 0 when the vehicle's not moving, so you just put the needle on pointing to 0 and you're good there. But like for example here, you'll have to drive your car to a gas station, fill the tank all the way up, and then after a couple miles stick this gauge on with the needle pointing just past full, and then you'll have to let the car warm up all the way and then stick this needle on pointing right in the middle, and so on and so forth for the rest of them. And I'm here to tell you that that is not true. You can 100% set all of your gauges up before you even close up the gauge cluster and stick it in your car. And you only need 4 simple things to do it. Number 1, a 12-volt supply of any kind. Now, I have this fancy power supply here. You don't need that. You can take a 12-volt wall adapter and just snip it off, use that. You can use 2 6-volt lantern batteries. You can use the car battery itself if you have just no other source of 12 volts. If you have radio controlled stuff, you may have a 3-cell LiPo. This will absolutely work. Just any source of 12 volts that you can get your hands on will work for this. So number 2, what you're going to need is a set of alligator clip cables. Now, if you've never seen these before, it's basically these little cables with a grabber bit here on both ends. And it's really nice because you can just stick them on and it'll hold itself in place. You don't have to take a loose wire and hold it against a terminal and look at your gauges, make sure everything's working like you want it to. Really just a convenient thing to have. They're like $6 for a set of 10 on Amazon. There's 5 in this bundle, and that should be plenty. That's all I think you're really going to need, but they are cheap. The third thing that you might need is a potentiometer. So what this is a variable resistor. So it has 0 resistance when you turn the knob one way, and then you spin it all the way to the other side, and it has whatever the rated resistance is, in this case 200. So I spin the knob all the way the other way, and it has 200 ohms on this side. And you can get them in 100 ohms, 200 ohms, 500, 1000. I wouldn't go for this application that we're trying to do here. I wouldn't go much above 5,000 ohms. So you'll need one of these. They're like $6 on Amazon. But just to make things a little bit cheaper, if you have an old piece of electronic equipment with a volume knob, so like a radio or a set of speakers, chances are the volume knob is a potentiometer. That's what you're spinning. So if you were planning on throwing it away, you can actually just pull the knob off, open it up, cut the wires, and then just take this out and scavenge one for free. And then you don't have to buy that. And the final thing you're going to need, and this is the scary one, is a PWM waveform generator, which sounds like a lot of fancy nerd words, and what it basically does is you hook up 12 volts to these wires here, and then this blue wire here turns on and off at a frequency that you set and duty cycle that you set. So when it's on, there'll be 12 volts coming out, and then when it's off, it's 0 volts, it's grounded. And so for example, you set to 1 hertz, it's going to switch on one time and then off 1 time per second. So 5 hertz, it's going to switch on and off 5 times per second, etc. Duty cycle, don't even worry about duty cycle. I've taken the liberty of measuring the tach signal off the ignition module with an oscilloscope. I'm going to just, all you have to do is punch in the numbers that I show you, and it's going to work fantastic, I promise. So this looks like an expensive piece of kit or whatever, but I promise you it's $12 on Amazon. All of this stuff is very, very cheap. And so with all this and a 12-volt source, you can set up all your gauges. So let me show you how that's done. All right, so I've set up a little test setup here, and we're going to start with the 3 small gauges on the cluster. So fuel, oil pressure, and water temp. And we will get to the tach a little bit later. So I'm going to explain, I'm going to flip this over, and I'm going to explain how each of these gauges work and what my test setup is doing so that we can slap the needles on the gauges. So at the back of each of these gauges, you'll notice there's 3 terminals. So 1, 2, 3 on here, and 1, 2, 3 over here. And 2 of these terminals are for power. So IGN is your switched 12 volts because you don't want your your gauges on when the key is off and removed from the vehicle. So that's on when the key is in the vehicle and turned on. This is pretty self-explanatory. That's the negative connection. That's your ground. That's negative to the battery. And each of the gauges has this 3rd terminal that's labeled something unique. So on your fuel gauge, you have fuel M over here. On the oil pressure sender, you have oil U. And on the temperature, you have temp M for your water temperature. So all of the gauges, including the tachometer, all have the same, they're all connected, their IGNs are connected together and their minus terminals are connected together. So that's what we're doing here. We're powering the gauge with this red and black wire. So I'm taking 12 volts from my supply and feeding it here. And by powering one of these, we power all the gauges, which is pretty convenient. The other thing is the 3rd terminal. This is how each of the gauges knows, where to move the needle. And the way this works is each of the senders, so the oil pressure sender that's in your block or the water temperature sender that's screwed into the back of the motor, all that really is a variable resistor, kind of like this one, except without the knob. The resistance changes based on whatever it's trying to measure. So for example, the water temperature sensor, it has a resistance that changes with the water temperature, or the oil pressure sender. It has a high resistance when there's no oil pressure, so that very little current goes from oil U to ground, and the needle reads low. And then as the pressure builds, the resistance drops, more current can flow from oil U to ground, and the needle starts pointing higher on the gauge. So we've basically replaced the sender, so from temp M to ground here, with a variable resistor. Now, here's the cool thing. This is just a resistor. It doesn't matter how you hook it up. I can reverse these 2 wires. I can reverse these 2 wires. I can take this wire and clip it onto the other side. Doesn't matter. The only thing that matters is that one of the wires comes from this middle terminal and one of the wires comes from one of these edge terminals. Doesn't matter which one. And you're going to clip one wire to temp M, or whatever the appropriate one is, oil U, fuel M, and the other wire is going to clip to minus terminal, the same minus terminal you hooked your negative of your power supply to. And let me flip this carefully because I've only got one hand here. Back, there we go. And I'm actually going to power it up and show you what happens. So here comes 12 volts, and you'll see the needle started to move. Now I can take my knob, rotate it, and make the needle read whatever I want. So what I'm going to try and do is, and I'm going to do this with one hand, so it might be a little bit shaky because I'm holding a cell phone camera, which is not ideal, but it's all I've got. And I'm trying to rotate this guy, which is a little bit sensitive, with just one hand here. So this is going to maybe take a little bit. Oh, I think I got it. I'm trying to put it right in the middle. And then I'm going to power down. And I'm going to power up and see if it comes right up to the middle. It's coming up just a little bit past it, so I'm going to just barely move that. Yeah. Oh, maybe that's close enough. So power down, let the needle fall, power up. And no, I overdid it. Yeah, it's a little bit difficult to do with one hand, but the point of the exercise is to have it so that when you connect your 12 volts, the needle goes from the leftmost side of the gauge right up to, oh, that's pretty close, the middle. And you know, it'll take a little trial and error here. But once you've got this set, you leave this alone, and then you know that when you power the gauge up, the needle will come up to the middle. So now you can power down, remove the needle, switch out the gauge face, and then set everything back up. Again, remember, not moving this knob here. And then you're going to power the gauge back on. It's going to rotate that little spindle to where it believes it's pointing the needle in the middle of the gauge. And then you're just going to slap on the needle pointing straight up and down, because that was the reading you got, and remember, you hadn't moved this thing. And then you can test it again by powering down, letting the needle fall, powering back up, and making sure that the needle points right in the middle of the gauge. And you can do that for all three of these. So you adjust this guy until the gauge is pointing right in the middle, and then you've got a reference point right here set. So you can pull the gauge needle off, change the face, then turn the power back on. That little, the little spindle where the needle pushes on is going to rotate so that it thinks it's pointing in the middle, and then you're just going to push on the needle pointing straight in the middle of the gauge. And then check it by powering down and powering back on. And so that's how you can set all three of these without even closing up the gauge face. So now I'm going to set up to do the tachometer. I'm going to pause the video and come back in just a little bit. So I have the setup here ready to test the tachometer. And what we've done is, I'm going to flip this over so you can see a little bit better. We've left the power wires alone because, as I've mentioned before, the IGN or ignition pins on all the gauges and the minus pins on all the gauges are tied together. So as long as I'm putting power in here, all the gauges are getting power. So we just kind of left that alone. Now what I have done is also hooked up power and ground from the supply to our little magic voodoo box here. And this is going to provide the frequency to drive our tachometer. So I've hooked up the PWM output, the blue wire in this case, to this gauge here. Let me try and get a nice reading on that. There you go, TM. That's where you want to connect it, right there. And let's flip this over. So how does the tachometer work? Well, basically, every time the ignition module fires a pulse or fires a spark plug, it sends a pulse on the tach line to the tachometer. And so the tachometer counts the number of pulses per given unit time, and it moves the needle to correspond with a reading on the gauge. So to get a ballpark number of how many pulses you need per second to get a certain reading, 1000, 2000 RPM, etc. You would basically multiply the RPM by the number of pulses per rotation of the crank. Now, on a Miata motor, there are 4 cylinders, so every 2 rotations of the crank, each cylinder fires once. So that's 4 pulses every 2 revolutions, or 2 pulses every revolution. So to read 1000 RPM, theoretically, we should be feeding in 2000 pulses a minute, or since we want it in cycles per second, divide by 60, about 33 and change hertz is the frequency that we should be feeding in here. Now, I told you I would tell you about duty cycle. Here's the number for duty cycle. I'm going to power everything on. It's 10. Just feed in 10. 10 works really well. And you can take, at 10% duty cycle, you can take the RPM from 1000. Let me autofocus here. All the way up as high as you'd like. Red line? Sure. There you go. There's $8,000 for you. And let me bring it back down. So, oops. There you go. 3000 or 33 RPM or 33 hertz. So that gives me about 1000 RPM, more or less. And then 2000. And every module may be a little bit different. So it's good to just test a couple of points with your particular gauge. So there you go. That's pointing right at 2000. I'm going to power down and make sure it comes right back up to 2000. Yes, that's perfect. So that's it should be 66, but it's 62 on my particular gauge. So the next one should be another 33 hertz and change above that. So theoretically 99, but in actuality for my particular gauge, 91 gets me 3000. Gonna go ahead and flick that. Oh, actually, looks like we do have to go a little higher. There you go. So I'm gonna power that down. Power back up. 3000 at 94 hertz. I'm going to crank up the frequency again to, what is it, 132-ish is what's supposed to. Actually, that one's pretty close. And that should give me $4,000 when I power up. And so you would write these numbers down. So 1000, when I power up, 33 hertz gets me 1000 RPM. And 62 gets me 2000 RPM. And 94 gets me 3000 RPM. And then pick one. So in this case, I like middle of the gauge just because personal preference. So I would calibrate at 132 hertz or 4000 RPM. Pretty much right on the nose. Actually, looks like if we set that down to 131, that'll get us, there you go, right on the nose at $4,000. So what I would do is now power off the gauge, pop the needle off, take the face out, replace it, and then before I put the needle on, power the gauge up again, and the little spindle will rotate to 4000 RPM, and then I just press the needle on at 4000. And to test, to make sure I have it in the right position, power off, power back on, make sure the gauge comes right up to $4,000, and then test another point. Move back down to 94 hertz for this particular gauge, and then power off, power on, and check to make sure that it moves to here. I'll actually do it. So make sure that there you go, 94, power off, power on. Make sure that it comes right up to 3000 RPM, and then do 62 hertz and do 33 hertz and do a couple of points along the rev range here and make sure that your needle moves to the appropriate spot. And if it does, then you have replaced the face on the tachometer and calibrated it successfully without having to put it in the car first and then drive around and kind of guesstimate it. It's set correctly. All right, so I have the old gauge faces off, and I have the needles painted and some of the gauge faces reinstalled. primarily the oil and the coolant temperature. So, because I decided to do all of them at once, I had to actually write down what the resistance of this potentiometer was for each of these points. And so I have this here. So I've got my tach readings here, what frequency corresponds with what RPM on my tach. And then I've got what resistance value corresponds with, for example, half fuel and full fuel, like 90 degrees C. Let me focus in on that. There you go. 90 degrees C and max. And same thing with oil pressure for the different PSI readings. And because I have access to these, or this fancy little tool called a multimeter, there you go, I can actually measure the resistance of this guy before I hook it in circuit. And so right now I have it set to as close as I can to 26.4, which if we look at the coolant temp should correspond to 90 degrees. It actually should be just a hair under. If we're being super duper exact, that's just what the closest I was able to get it to, coming up to exactly in the middle of the gauge. So I'm going to try and do this with one hand, and it's probably going to shake the camera around a ton and not be great. But I'm going to try and connect the alligator clips here with just one hand. That's very sketchy looking, but it should work. And I'll connect this guy to temp M, which is that little screw head right there. Please work. Oh my god, that actually might work. Alright, and now I'm going to apply power and see if I set the needle correctly. Oh, that's pretty darn close, actually, to where it was. Actually, that's exactly where it was. Just a hair under the middle of the gauge. That's perfect. And then I'm gonna mess around with this guy, make sure I can make the temp fall. Well, actually it never did fall all the way on the old gauge. And then because my potentiometer doesn't have a high enough resistance to make it go all the way down, but I do have more than enough to make the gauge peg out, and peg out it does. Awesome. So this is working perfectly. I've already done the oil gauge, but I wanted to capture doing the coolant gauge on camera. And now I'm going to go ahead and finish up the rest of these. I'll probably try and capture the tachometer on camera too, because it's a little bit easier to set up this digital box that I just push buttons on with one hand and make the gauge do stuff. So I'll continue reassembly, and I'll come back when that has been reassembled. Nice. So, look at these gauges. I love this. This is so cool. They're all installed. The last gauge I installed was the tachometer, and I noticed something interesting. I held this guy, the old face, close to, just hovered right on top of the other one, and I noticed that they don't line up as well as I thought they would. And then I realized after scratching my head for a little bit that this one is deformed. I mean, that's why it's peeling up and, had to be replaced. So I really shouldn't have trusted the readings on this guy to set this. So these are probably a little bit off. So we're going to go ahead and use the theoretical 33 and a third hertz per 1000 RPM. And it should be close. So I'm not sure, whether this gauge, I trust this one more than this one. But hopefully we're at least in the ballpark of 1000 or 2000 or 3000 when we set it up. So I forgot what frequency I had this set to. Looks like it was $3,000, and I'm at, can't see that, 95 hertz. So pretty close to the 99-ish that we were expecting. So if I go up to 99, you'll see it seems to shoot past it a little bit, but not by much. We're pretty close. I'm going to go down to 66, which is where we're supposed to be for $2,000. And jumps just a little bit past it, so pretty close there. 33. So remember, we got to power the gauge off and then turn it back on and see if it jumps to that RPM number. Again, pretty darn close. And if we actually do so for example, I'm going to do 35. Oops. I'm going to set to 35 hertz, and you'll see it shoots past, it shoots past 1000 RPM. And I'm going to hold this as absolutely close to centered as I can. And if I kind of pull it up and away, you'll see the zeros are centered, the ones are not, and it's actually pointing where the one used to be. So I did put the needle back exactly where it was. It's at 35 hertz, it's pointing to 1000 RPM on this old gauge, but again, deformed old gauges, and the theoretical value should be 33, so we're going to try 33 here. And that's much closer. It's pretty much right on it. Not too bad. We're going to go back up again. We already did 2 and 3,000, so I think 132 is what 4,000 is supposed to be, more or less. Oh, that's beautiful. And then like 165. So we're adding 33 hertz to the frequency every time to jump up 1000 RPM. So power the gauge off, power it back on. What are we getting? Boom! That is beautiful. So add another 33 to 165, 198. Man, I didn't want to math this late at night, but fine, sure, let's do it. Oh my goodness. Perfect. All right, I think that's enough points, and in fact, actually, I stopped.
And unfortunately, this is where the audio cuts out for the rest of the clip. I'm not sure why this happens, and it's happened to me before, but this is why I don't like using the cell phone camera. Anyway, what I was saying was once you finish up testing the needle at various points and it's to your liking, then you have installed all of your faces. So all that's left to do is to install the cover and put the cluster back into your car for final verification.
Just as I shut the camera off, I remembered there's one last piece of advice that I wanted to give. So this is if you ordered a set of LEDs with your rev limiter gauges. Now, these have a polarity, so you have to put them in a certain way. And it's not so bad right now with the dash out. If you reverse it and the LED doesn't light, you just flip the bulb around. But if you have reassembled the dash into your car, this can be a real pain in the ass because you got to rip everything back out again. So to test it, you take your handy dandy 12 volt supply and you wire it to the following terminals, and I'm going to try and focus in here. There you go. So you'll see one right here saying ILL plus, and then right below it ILL minus. That's illumination plus, illumination positive, and illumination negative. So you can just very carefully with a flat blade screwdriver pry up a little bit on this ribbon part here and clip onto obviously your positive to ILL plus and the negative of your source to ILL minus. And with that connected, you can position your gauges. Let me adjust the zoom here, and we're going to switch on. And it looks almost all of them worked. So you can see, I believe I have that one backwards because it's not lit. No problem. I'll do this even with the power applied. All you got to do is take this bad boy out. Hang on, just the focus. There you go. Take this bad boy out, flip it 180, boom. And you saw how much brighter that got, so that bulb is now working. Done. You see how easy that was now versus turning on the lights in your car after everything had been assembled and then finding that this one was dead? So that's the last bit of advice I really got for you. I'm going to go ahead and assemble these or assemble this gauge pod into the car and enjoy these brand new set of gauges. Alright, one more video. So the last step in the rev limiter gauge face install is to install the needles, but we have already done that, so we're just verifying that they all work. Went for a drive, filled up the tank, fuel gauge reads full, idle oil pressure is right on 30. The coolant is supposed to be, according to the installed at 1130 is the recommended position, and that's pretty darn close. And the tachometer I verified with a timing light, and it's pretty close. So I'm pretty happy with this gauge install right here. One last thing, I'm going to turn off the car and make sure all the gauges fall. So there's 0 positions, nice. Yep, there we go. That one rises back up. Those point where they need to point. Awesome. There it is. Done.